Good morning, afternoon, evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra 2 class. Today we're going to start talking about ratios and proportions. And right off the bat, guys, a ratio is a comparison of two values of the same unit via division. I want you to understand that I emphasize same units, okay? We're going to discuss this a little bit later in great detail. But when you have a ratio, it's basically a fraction, but it's a fraction made up of the same units. So if we're talking about the ratio of boys to girls, that's the same unit. They're both humans. If we're talking about the ratio of, short-haired dogs and long-haired dogs, that's still the same unit. They're humans. If we're talking the ratio of questions answered correctly and questions answered incorrectly, we're still talking about the same unit, which is questions. So a comparison of two values of, again, guys, the same units via division. Ratios can be expressed in not on, but in one of the following ways. I apologize about that. That is my bad. And it can be written as A to B, where a colon is used to differentiate the two different values. Bless you. They can have A over B in a fraction form. By the way, this is basically the best and most useful way right here. Okay, that's going to be your go-to whenever we're using this in math to solve problems. And then you have literally A to B with the word to. Okay? But by far, there's no doubt that the most important one is this guy right here. So that's what a ratio is. That's how you can write a ratio. Let's write some ratios. Write each ratio in fractional form. Sometimes I've seen in the SAT, they'll tell you write in three different forms. You know the three different forms are right there. But for the most part, it's going to be a fractional form, gentlemen. So the ratio of boys to girls in a classroom is 5 to 7. How do we do that? It's 5 over 7. Now, why did we put the 5 in the numerator? Go ahead, guys. Why? Okay, you guys are giving me crazy answers. Think about this. Why? No, it did not say it has to be a smaller number. No. Thank you, sir. Doesn't it, guys? Doesn't the ratio of boys to girls, isn't that just like this, guys? So isn't the first number the numerator? And isn't the second number or value the denominator? So it's not because one was smaller or larger. You read. So this is 5 boys to 7 girls. But if I had told you the ratio of girls to boys, I want the ratio of girls to boys, what would the ratio be? Right, 7 over 5. 7 girls to 5 boys. If I said girls to boys. Great. Good. Okay, the ratio of A's to B's in the class is 9 to 14. What's my ratio? 9 whats? 9 whats? 9 A's for every 14 B's. Yes. Now you may say, more, that's not the same unit. Yes, it is. They're grades. Grades are all, it's the same unit. Now, this one really beats up a lot of my boys. So let's really focus on this and let's take our time. The ratio of 4 3/4 to 2 1/5. Well, this is 4 3/4 to 2 1/5. Okay, that's fantastic. That cannot be left like that, though. Yes, sir. Yep, that cannot be left like that. Okay, guys? What do we have here? We have a division of fractions, don't we? We have a division of two mixed numbers, right? So what magical song did I teach you? Stay, change, flip. Exactly. However, can I stay, change, flip mixed numbers? So what's the first thing I've got to do? You got to make them improper. So 4 3/4 becomes 19/4. Excellent. And then 2 1/5 becomes 11/5. Yes, sir. You have a question, my brother? Thank you. No, please. Because 4 times 4 is 16, plus the 3 is 19, my brother. We're going from mixed number to improper fraction. Correct. You're multiplying the numerator times the whole number, and then you're adding the numerator, and then you're placing it over the original denominator. Just for below, yeah, look. 2 and 1/5 became 11/5. Anytime we're going from a mixed number to an improper fraction, you're going to multiply the denominator times the whole number, which in this case is 20, plus the numerator, which is 21 then, over the original denominator of 4. Thank you, my brother. Thank you for your honesty. Takes guts. Good job. Okay, so now I have them in fractions. So now I go stay, change, flip. Guys, the whole point of knowing fractions is to take away the fear. Most people see this right here and they panic. Oh my God, what do I do? What you do is take your time, take a deep breath, and look at it. You have the skills. Oh, wait a second. This is a mixed number. Let me turn it into an improper. This is a mixed number. Let me turn it into an improper. Oh, I'm dividing fractions. Stay, change, flip. So my answer here is going to be 50 and 45, so that's 95 over 44, or 2 and 7/44. Yep. Or either or, unless I specify. Leave an improper fraction, leave a mixed number. Does that make sense, guys? See, I told you that'd be a good example. I knew it. If we look at number 4, it says 8 gallons to 4 gallons. What's the ratio there? Yeah, you got 8 over 12. Now, whenever we have a ratio, we always want to reduce it. So what would that reduce to, my brothers? Yes, you can divide 2 to both the numerator and denominator. So that would be my ratio. Okay, 2 gallons to 3 gallons. That makes sense? May I continue? Thank you, gentlemen. Now, let's see. I've got 6 meters to 30 centimeters. What do I got here? Yes, sir. Oh, man. You just made me so happy. That's right, buddy. First of all, my boy just realized, he probably said, okay, going to put 6 meters to 30 centimeters. And then he probably said, wait a second. This is technically not a ratio because this is not in the same units. Morrow specifically said that it's a ratio when they're the same units. So how do I go from meters to centimeters? Yes, sir, my brother. How do we go from meters to centimeters? Yes, sir. Yes. Okay, we're going to ask again. How do we do it? No. Okay, you guys are giving me a lot of good stuff, and I'm proud of you, but none of it is right. Yes, sir. Okay, no. Okay, hold on, guys. Hold on. I'm going to show you the easy way, okay? King Henry died, unfortunately, drinking chocolate milk, okay? This is kilo, hecto, deca, the unit, so we're talking about grams, liters, or meters, deci, centi, and milli. Where am I here? 6 meters. Where am I here in my little chart here? You're right here at the middle, in the center. Where am I going? So I'm going 1, 2 to the 2 places to the right. So take this 6 and go 1, 2 to the right. Essentially, I'm multiplying by 100. So 600 centimeters now over 30 centimeters now, when I reduce that, will equal 5 over 1. Does that make sense? Yes, sir. Yes, there was a reason I didn't go from centimeters to meters, because I wanted to convert meters to centimeters. If you wanted to go from centimeters to meters, then yes, then you would have moved to the left. But I chose to go from meters to centimeters. I wanted to multiply instead of divide. Now, guys, you guys have studied unit analysis, correct? Well, if you study unit analysis, remember, this is very elementary here, what I did. That's not really the way scientists want this done. Unit analysis, you have to understand that when we're getting to smaller metrics, you're multiplying by powers of 10 when you're going from the grams. Yes, sir?
Why is it then 600 over 30? How is that equal to 5?
It would be 50 because I don't know how to divide. That's why it would be like that, because I don't know how to divide.
Wouldn't it be 20?
But hey, wow. Mr. Morrow really doesn't know how to divide today. Yeah, it would not be 50 or 5. It'd be 20 though. That'd be good if you did that correctly, Morrow. Thank you very much, sir. So, guys, when you're going from unit to a smaller unit in the metric system, you're multiplying by powers of 10. Okay? When you're going from the unit to larger units of the metric system, you're dividing by powers of 10. Okay? So unit analysis wise, it would be like this. Unit analysis would be like this. I'm going from meters to centimeters, right? On this top one, right? Okay. So I'm going from a meter to a centimeter. So I'm going from large to small. So I'm always going to multiply. So I'm going to multiply by 100 centimeters per 1 meter. What happens here? The meters cancel. And now I have 6 times 100, so that becomes 600 centimeters over 30 centimeters, which when you do it correctly gives you 20 centimeters to 1 centimeter. Does that make sense, guys? You may want to look at your unit analysis or dimensional analysis notes from chemistry or physical science. If not, please come see me and we'll work on it together, okay? Does that make sense, though, guys? But the key here, the real big key here, was that you guys noticed that centimeters and meters were not the same unit. Very proud of you. Great job. Thank you. Okay, now, a rate. We know what a ratio is. We know how to define a ratio. We know how to write a ratio in 3 different ways. But what is a rate? Well, a rate is a ratio involving different units, guys. For example, 28 miles over 3 hours. Those are 2 different units. That's a rate. You can type 98 words and 92 words in 3 minutes. That's a rate. Okay? 185 in 4 days. I don't even know what I was trying to put there. 185, let's say, okay, cookies. Yeah, let's do it. I like that one, though. 185 cookies that you ate in 4 days. You are not a healthy person then. You are not a healthy person by any stretch of the imagination. No, but I'm just joking. Does that make sense, guys? Different units, my brothers. Okay? That's what a rate is. Now, there's a specific kind of rate that involves money. And it's called unit price. And unit price is a rate with a denominator of 1, of course, okay? But in order to find a unit rate, simply divide the ratio in order to make the denominator 1. When you have a unit price, okay? For example, find the unit, well, no, I'm sorry. What am I doing? Why did I go to unit price when I'm talking about unit rate? I had a long day yesterday, guys, and I guess my brain isn't with me, so let me start that again. We know ratio, we know rate. What is a unit rate? A unit rate is a rate with a denominator of 1. We'll get to unit price in a second. I'm sorry about that. In order to find a unit rate, you simply divide the rate that you were given. So you have a denominator of 1. Give me 1 second, my brother. For example, find the unit rate of driving 248 miles in 4 hours. My rate will be 248 miles in 4 hours. That's my rate. What's my unit rate? I just divide it. So 248 divided by 4 is going to give me 62 miles per 1 hour. This is my unit rate because it explains how far did I go in 1 unit of time. Yes, sir, my brother.
So whatever it gives you, you just divide it and then you put the answer on the one.
Correct. Whenever you're given a rate and you want a unit rate, you literally divide so you can find a denominator of 1. No, thank you. So for example, let's say I tell you that I can grade 12 papers in let's say 6 minutes. I want my unit rate. What's the unit rate here? 2 papers per minute. 6 divided by 2 is, 12 divided by 6 is 2. So 2 papers per 1 minute. That's a unit rate. Does that make sense, brothers? Now I can start talking about what I thought we were on already. Sorry. Unit price. Okay. Unit price is a unit rate, but involving money, y'all. Unit price of an item is the price per ounce for 1 unit of the original quantity. And it is expressed as the formula below. Unit price always has the following formula. It's the price. I don't like this. You know what? Hold on. Why is this doing this to me? There we go. I don't like that. Let's just put price. Total price over total quantity. That's what I wanted. So it's the price over quantity. That's how you find your unit rate. Total price over total quantity. This is really important when you go shopping. I'm sure this has happened to you or to one of your parents or friends or girlfriend or somebody you know for sure. It will happen to you eventually once you start buying things. At stores, a lot of times you'll see, oh, get 3 cans for whatever, $5.82. And then 1 can is $1.46. An educated buyer, an educated consumer asks themselves, which is the better deal? Now, I know that sometimes we don't think about that because we say, what is 3 cents? Right? What's a nickel? Who cares? Well, guys, over time, nickels become dollars. And those becomes tens of dollars and hundreds of dollars, et cetera, et cetera. So this is very important, not just for this class and for math and the SAT and the ACT, but for your own consumer life. Every single one of us is going to buy something. Every one of us. Might as well know how to get the best deal, right? How to get the most bang for your buck. You work hard for your money. Let's spend it wisely. So for example, let's say you have to buy some stuff at the store and you want to find the better buy between 8 cans of tuna for $8.75 or 12 cans of tuna for $25.50. Now, you may say to yourself, oh, I know this already by looking at it, Moro. I guarantee you don't. Okay, you got to actually divide it. So let's find each unit price. So the unit price here is price per quantity. So price of $18.75 over the quantity of 8. That is going to give me a unit price of $2.343, which I'm going to round to $2.34 per 1 can. So for the first deal, I'm paying $2.34 per can. Excuse me for 1 second. All right, thanks for that little break there, guys. All right, so now the next one, we've got the price. The next unit price here is price over quantity. So I've got 25.50 divided by 12, and that's going to give me a unit price of 12 and 1.125. So that's $2.13. So who is the better buy? 12 cans for 25.50. This can be very misleading because someone says 25.50, 1875. Nah, the 1875. Yeah, you're going to spend less money at the moment, but you're getting more for your money on the second one. Yes, sir, my brother. Thank you. Because I use the formula unit price, price over quantity. Does that make sense? Why are you saying sorry? Because you care? Thank you. You never apologize for wanting to learn. May I continue? You got it, my brothers? You sure, Baba? I see you writing. You got it? Okay, thank you. Okay, now, let's continue. Proportion. A proportion is, as you notice, guys, I didn't blank this out because there's a lot of stuff here. So I don't want you to be jammed up on writing. I want you to really understand and listen. A proportion is a set of two equal ratios, period. When you have two ratios that are equal, that is a proportion. The unit price of an item is the price per ounce of one unit. And is expressed, what the heck? Wow. Wow, this is an epic fail, guys. I made so many mistakes on this, and there's no excuse. Okay. You can check for proportionality by cross multiplying and comparing the cross products. If the cross products are equal, then the ratios are equal and you have a proportion. So for example, if I say, do I represent a proportion with this, or is this a proportion? And I say 5/8 equals, let's say, 20, 30 seconds. Let's see. 32 times 5 is 160. 8 times 20 is 160. Are the cross products equal? So this is, yes, it is proportional. It is proportional. Does that make sense, guys? Promise? So that's how you can tell if two ratios are proportional. You literally just cross multiply them. Also, I want you guys to understand this. You don't need to cross multiply all the time if you're savvy with your multiplication tables. What did I multiply to 8 to get the 4, gentlemen? What did I multiply to 8 to get the 32? And what do I multiply to 5 to get to 20? What do you notice there? They're the same, right? So what is the value of 4 over 4? 1. So what are we basically doing? We're just finding equivalent fractions. So remember when we learned equivalent fractions in quarter 1, I said, guys, this is going to be very important forever. You see now how it's coming back to you? So now it's either going to help you or it's going to haunt you. One of the two. Okay, but this is how you can test for proportionality. Okay, so using proportions to solve problems. Number 1, find the fact ratio. What is a fact ratio? That's the fact that they give you. They're always going to give you a fact. John can cut 12 trees in 5 hours, or Mary can bake 42 cakes in 12 hours. They're always going to give you a fact of some sort. Okay, that's your fact ratio. Then set up a proportion, making sure that you go from same unit to same unit. What am I talking about? If the fact they give you, you have feet and hours, when you're setting up the proportion, you have to put your feet to hours. Unit to unit, unit to unit. You don't want to mix and match your units. You don't want to have feet over hours and then hours over feet. You're not matching your units. And then you literally solve the proportion by cross multiplying. Literally. So for example, guys, if a teacher can grade 3 tests in 15 minutes, how many tests can he or she grade in 2 hours? Okay, what is the fact ratio that they gave you? I can grade 3, or the teacher can grade 3 tests in 15 minutes. Now, I want to find out how many tests I can grade in 2 hours. So, what am I looking for? What am I looking for? Okay, I'm not asking you what to do. I said, what am I looking for? How many tests? So, test to test. So, X tests over, not 2 hours. I have not 20 minutes either. 120 minutes, yes. I converted hours to minutes. Remember, guys, gotta stay consistent. So now, this is very simple. Cross multiply. So this is 3x, I'm sorry, 15x equals 360, thank you, my brother, divided by 15. So 15 on the outside, 360 in here, that's a 2. So 24 tests. So I can grade 24 tests in 2 hours. That's the power of proportions. Does that make sense? Any questions, boys? I know we've got a lot of vocab, a lot of stuff today. Any questions so far, my brothers? I'm here for you guys. Okay. Let's do another one then. Example 3. Mark needs 8 cups of flour to make 12 gourmet cupcakes. He has 20 cups of flour. Does he have enough flour to make 60 gourmet cupcakes? If not, how many more cups of flour does he need in order to make the 60 gourmet cupcakes? I put a lot of information here on purpose. What is the fact that they give you? What fact do you know? Yes, sir, my brother. Okay, you got 8 cups of flour to make 12 gourmet cupcakes. Beautiful, my brother. Now, how do we solve the problem? He's got 20 cups. He wants to make 60 gourmet cupcakes. What do I do here? Go, keep going with it, my brother. Phenomenal. No, not good try. Good, phenomenal try, but not a phenomenal answer. Talk to me. Yes, I got 20 cups of flour over X gourmet cookies. Let's go ahead and cross multiply. Cross multiply. So I got 8x equals 240 divided by 8. So x equals 30. 30 what? Gourmet cupcakes. That's why I label my brothers. So do I have enough flour? No. So how many more cups of flour does he need? Okay, exactly. I got 30. I need to double it, right? So that means I need to double the amount of flour. Or you could look at it like this, guys. 8 cups of flour gives you 12 gourmet cupcakes. How many cups of flour will give you 60 gourmet cupcakes? You could do it that way too, right? And then you're going to get 480 equals 12x divided by 12. So x would equal 40 cups of flour. So you need 40 in total. You only have 20. So at the end of the day, I need 20 more cups of flour. So there's 2 ways to skin that cat. Does that make sense? Yes, sir, my brother. I'm sorry, my brother? Okay, the question was, can we do it the second way every time? Absolutely. I mean, in this particular case, yeah, absolutely, my man. Because you found something to find something else. You had 2 choices here. You could have first found the original, then figured out, okay, I need 30 more, so I need another 20 cups of flour. Or from the get-go, you could have said, how many cups of flour is it going to take in total to make these 60 gourmet cupcakes? Oh, I'm going to need 40. I have 20. How many do I need? 20. Does that make sense? Great question. Yes, sir, my brother. The answer would be, I need 20 more cups of flour. Does that make sense, kid? Does that make sense, everybody? Great questions. Okay, and then here, guys, last but not least, you can cross multiply or you can know your times tables really well. In this first case, guys, look at some number compatibilities. We can cross multiply, yeah, and if you want to, go ahead and do it. However, what did I do to 9 to get to 27? So whatever I do to the denominator, I must do to the numerator. So x equals 15. Thank you. If you wanted to cross multiply, it would have been 135 equals 9x and then divide. Here you're kind of out of luck, Chuck. So this is 0.3w equals 1.05 divided by 0.3. W equals 0.3, 1.05, 1 to the right, 1 to the right, 3, that's 9, 15, 5. So that's going to be 3.5 equals W. Now, if I have x plus 5 over 4, actually, wait. What do I have left here? Okay, I got a couple more pages, and I'm not going to do that to you. So look, this is all I'm going to ask for you guys to do. Make sure that you know every definition that we did today, ratio, rate, unit price, proportions. I'm going to give you a little quiz on it tomorrow before we continue the lesson. Your homework is simply to learn and make sure you know for sure what we did today. And also, by the way, I don't know if you guys noticed, prep works I graded already, so if you haven't done it, do it now. Thank you. Have a great day. God bless you all. Thank you for a great lesson. Hope you learned a lot.